Hello class, this is Miss Riggins and I'm here to talk about properties of parallelograms or parallelogram properties. Now you're familiar with parallelograms from middle school, but did you know that every parallelogram has four major properties? Well, today we're going to discuss those four major properties. So let's take a look. Here we have a parallelogram, and by definition a parallelogram is a quadrilateral with two pairs of opposite parallel sides, as we can see. So let's take a look at the side lengths of this quadrilateral parallelograms. As you can see, these are the side lengths of this parallelogram. Do you notice any patterns with these parallelograms? Do you notice any patterns of these parallelograms? Of these side lengths. Well, let's see. If I change the parallelogram, do you still see the same pattern? As I change the side lengths, do you still see the same pattern? Yes, and what you should see is that opposite sides of the parallelogram are the same length, which means they're congruent. Opposite sides of a parallelogram are congruent. So that's one of the first properties. Opposite sides of a parallelogram are congruent. Now let's take a look at the angles. Here are the angle measurements of this parallelogram, and as I change the parallelogram, do you notice any patterns that seem to occur with the angle measurements of a parallelogram? Well, some of you may also notice that opposite sides of a parallelogram are also congruent. Opposite angles of a parallelogram are also congruent. Opposite angles of a parallelogram are also congruent. So as I move the parallelogram around and change its size and its angles, one thing that seems to remain constant is that opposite angles are congruent, as you can see. Alright, so far we've talked about opposite sides of a parallelogram are congruent, and we talked about opposite angles are congruent. But let's go back to these angle measurements. What else do you notice about these angle pairs? We looked at opposite angles, but what about the adjacent angles? What do you notice about angles C and D? What do you notice about angle A and B? What do you notice about angle B and C? And what do you notice about angle D and A? Well, as you can see, they are different, but what do their angle sums add up to? Let's see. The measure of angle A plus B adds up to 180 degrees. So that means angles A and B are supplementary. So no matter how I change the parallelogram and the parallelogram's angles, adjacent angles are supplementary. Adjacent angles are supplementary. So no matter how I change my parallelogram, adjacent angles are still going to be supplementary. So we know now that even though opposite angles are congruent, the adjacent angles are going to be supplementary. And adjacent angles are angles that share a common side. And as you can see, angle B and angle C share a side BC, so they're adjacent, and they sum up to 180. So far we've looked at three properties of parallelograms, looking at their sides and their angles. Now let's take a look at the diagonals of a parallelogram. So as you can see, I have two diagonals of this parallelogram, and let's take a look at their measurements. AM is 4.84, BM is 2.49, CM is 4.84, and DM is 2.49. What did you notice? You notice that two pieces of a diagonal are congruent, which means that this diagonal is bisected at point M. But if you take a look at the other diagonal, you can see that the other pieces of the other diagonal are also congruent, which means M is not only the bisector of one of the diagonals, it's also the bisector of the other. So that means M is the midpoint of both diagonals. And if M is the midpoint of both diagonals, then that means that the diagonals are bisecting each other. The diagonals are bisecting each other. So now we can see four properties of parallelograms.